We're now going to turn our attention with evaluating functions and solving functions to where we have an equation to actually work with. Now what we're going to do is look at a lot of different types of functions, most of which you probably have been exposed to in a previous algebra class. So a lot of this might be review, but at the same time it might be stuff that we really need to review. So what I would say is if any of this looks completely unfamiliar, or if after us going through a couple together you're not feeling incredibly confident in it, then please stop by office hours or schedule an extra time with me to sit down and work through some of this stuff so that you can be successful in solving equations of the nature that you're going to see here. All right, so let's start with this function g of x here. All right, so they're first asking us to evaluate g of 3. So one thing right off the bat is that, you know, when we were looking at the table and the graph, we said that when we were asked to evaluate g of 3, it meant what is the y value when x is 3? So if x happens to show up in multiple places in the equation, then make sure that that particular value gets put in both of those or in all of those places. In this case, there's 2. And then we have to remember our order of operations, right? So this exponent's got to happen before this multiplication. So our next step would be 3 squared is 9. And then multiplication is going to happen before subtraction. So we get g of 3 is equal to 42, or when x equals 3, y is going to equal 42. All right, and then here's just another one, and it might be not a bad time to pause and just try this yourself. All right, but if you've done that, we're plugging in -1/2 everywhere we see an x in the formula, so 5 times -1/2 squared minus, and then careful here, you're subtracting because of this subtraction symbol, and then we got to plug x in, which is also negative, so we'll protect it with parentheses and say minus -1/2. All right, but again, we'll do the squaring first. Now a -1/2 squared is going to turn into positive 1/4. And while I'm at it, I can go ahead and simplify this. We know that anytime we see minus a negative, it really means plus a positive. And then we have 5 times 1/4, so 5/4 plus, and we know that we need a common denominator here in order to be able to add these, so I'll multiply the top and bottom by 2 and get plus 2/4, so my answer is 7/4. So g of -1/2 is equal to 7/4. Now in part C, we're going to solve g of x equals 4. So what that means is up here in this formula, I'm going to replace this g of x symbol with 4 because I know that it's 4, and I'm asking what are the x values that give me a y value of 4. So we'll say 4 equals 5x squared minus x. All right, so here's a quadratic equation for us to solve, and there are many different techniques to doing that, and throughout these next few examples, I'll kind of remind you of those different techniques. In this one, let's go ahead and solve by factoring. Okay. Remember that factoring is one of your techniques for solving a quadratic that doesn't necessarily work every time. The numbers have to work out correctly. But if you notice that factoring does work, it's definitely the fastest. So as a reminder, in factoring, what we're trying to do is we're trying to essentially reverse FOIL this. So I want to break it into a binomial times a binomial, where the first times the first gives me 5x squared. Well, the only way I can really do that is if I put a 5x in one of them and an x in the other. And then remember that the last times the last has to equal -4. And then the outside, 5x times this, plus the inside, x times this, has to equal the middle term, -x. So there's, at first what you might do is pencil in something that you know will make -4. So like, let's say I put a +2 and a -2 here. Okay, that would give me a -4 as here, like I need. But if I add the outside, which is -10x, plus the inside, which is 2x, that's going to give me -8x, which does not match this. So you check to see if you factored correctly by seeing if outside plus the inside gives you that middle term. Okay, so my try didn't work. That's okay though. Try something else. So we know that 1 times 4 is going to give me 4 as well. So how about we try to do +4 -1. So here I'm going to get a -4. 4 times -1 is -4. 5x times -1 is -5x, plus 4x is -x. So this one works. If I FOIL this thing back out again, I get 5x squared minus x minus 4. And then once you factored, the idea is if you have the product of two things equaling 0, then either the first one has to be 0 or the second one has to be 0. So here I'll say 5x plus 4 equals 0. So I just set each of them equal to 0 and solve. So here I get x equals -4/5. And here, a little easier, I get x equals 1. And so like we saw with our graph and table, it's possible that when we solve, we might get more than one x value that as an answer to that. All right, so there we just solved by factoring. All right, so now let's take a look at example number 4 here. So in example 4, we have f of t equals 6t cubed minus 26t squared minus 20t. All right, so we're going to set that equal to 0. So 0 equals all that. Now if we want to think along the lines of factoring, we can look at each of these terms and notice that there's actually a real easy version of factoring that we can definitely do. Remember, before you try to reverse FOIL things, that if you can see something in common in every term, you can pull it out. So I can see that all of these are even numbers, so I should be able to pull out a 2. And I have a t in every one of these terms as well, so that means I can pull out a 2t. So let's see what that leaves us with. 2t times 3t squared would give me 6t cubed. 2t times -13t gives me -26t squared. And then minus 10. Okay. All right, so what we have now is a similar situation to what we had up here, right? We have two things multiplied together equaling 0. And so what did we do in the last problem? We set each of those factors equal to 0. So we're going to do the same thing here. So on the one hand, we're going to say 2t equals 0. And if 2t equals 0, that of course means that t equals 0 is one of our possible solutions. Let's check out 3t squared minus 13t minus 10 equals 0. Now that in itself is a quadratic equation. So I could solve this by factoring if I wanted to, if it does factor. But let's do a different technique here. So even though solving by factoring is a possibility, this time let's solve with the quadratic formula. This may be most of your favorite to do whenever you have a quadratic equation, is just jump straight to the quadratic formula. And your reason for liking it is certainly understandable, because the quadratic formula works every time, whereas factoring doesn't. All right, so remember the quadratic formula, and I'll just put it up here if maybe we've forgotten. If you have ax squared plus bx plus c equals 0, then your solutions are x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so we can apply this here, recognizing this is a, this is b, and this is c. All right, so we would say t is equal to negative b. Well, if b is negative 13, it's the opposite of negative 13, plus or minus the square root of b squared, so negative 13 squared, minus 4 times a, which is 3, times c, which is negative 10. All divided by 2a, so 2 times 3. And then at this point, it's your job to clean this up. So t equals, this will be 13 plus or minus. So negative 13 squared gives us 169. This gives us plus 120. And that's all divided by 6. And we're kind of running out of space, so we'll go over here. So t is equal to 13 plus or minus the square root of 289 over 6. Now the square root of 289 is actually a perfect square. If you take the square root of 289, you get 17. So you should always check to see if your, if your number inside here is a perfect square before you assume that it's not. But we get 17 over 6. Sorry, let me fix this just a little bit. So it's plus or minus. Now never lose sight of what the plus or minus actually means. It literally means that you have two different t values. You have the t value where you use the plus sign, which is going to be 30 over 6, which is going to be 5. And then you have the t value where you use the minus sign, which is negative 4 over 6, which is negative 2/3. And so what we get here is 3 different solutions. T equals 0, t equals 5, and t equals negative 2/3. If you plug any of those 3 t's back into this original, right here into this original function, you will get 0 as was desired in the first place. So what you just saw was a couple examples where it was either a quadratic equation to solve from the get-go, or it looked a lot like one and you had to use similar techniques. So here we're going to take a look at functions that involve square roots. So in this case, f of x is equal to 5 plus the square root of x plus 3. All right, so first we're being asked to evaluate. So understand that here we're going back to saying that, what is y when x equals 78, right? So we're plugging 78 in for the x value. Another nice memory device to make sure you're distinguishing between evaluating and solving is usually evaluating goes much faster than solving does. So 5 plus the square root of 78 plus 3, well, that's 5 plus the square root of 81. 81 is a perfect square, so the square root of 81 is 9. So we get 14. So when you plug in an x value of 78 into this function, out comes an output of 14. All right, in part B, it asks us to solve f of x equals 12. So we're going to say, we're going to place 12, right, in the spot of f of x and set it equal to the expression from our function. All right, now at this point, you've got this function, this square root function, and then you have 5 plus that. So what I'm hoping that kind of reminds you of a little bit is if we go back to that graph problem, so go back here. Remember when we had 3 times g of x minus 2 equals 10, our first task was to get the g of x by itself, and then we were able to use the graph to figure out what the answer should be. So here, I would suggest we do the same thing. We've got this function type thing, the square root, but right now it's not all by itself. So let's start by getting it by itself. So we can subtract 5 from both sides, and we get 7 is equal to the square root of x plus 3. All right, now a principle that you probably have studied quite a bit in your previous algebra classes is this idea that when you're solving an equation, you're really undoing things. Okay, so you want to do kind of the opposite in order to get things by themselves. So let's think about what's the opposite of square rooting. Well, it would be squaring, right? So what I can do to this equation is I can square both sides. So I get 49 on the left. And then when you square a square root, they just zap each other. So you get x plus 3. So we subtract 3 from both sides. So 46 is equal to x. Now what you should always do, and this is just good practice generally, but especially with square root equations, it's good to go back and check to make sure that the solution you got actually works. So let's check 5, well, let me put it this way, f of 46, that would be 5 plus the square root of 46 plus 3. That would be 5 plus the square root of 49, 5 plus 7, which equals 12, which is exactly what we started with. So that means it checks out. Now the reason we are supposed to check with square root equations is because sometimes when you're solving, you can end up with fake solutions essentially. This wouldn't happen in this particular problem because there's a 7 here, but let's say there was something that involved x on this left side. What can possibly happen is when you square it, you can introduce extra or extraneous solutions into your solution set that you need to then kick out later. Just to give you the simple explanation for why, it's possible to have an equation that's completely bogus, like here's a really bogus equation, negative 3 equals 3, right? We all know that that's false. However, if I square both sides, all of a sudden it becomes true because 9 equals 9. So you got to be a little bit careful, and the way to make sure you haven't accidentally done that is just by checking and making sure that it all comes out right in the end. All right, so let's look at one other one, and I would suggest that you try this one first, see if you're comfortable with this technique of solving for solving equations that have square roots. All right, so if they're asking us to solve this, we know that we're going to plug 10 in where we saw g of x, right? So this will be 10 equals x squared plus 7 plus 6. And in that last problem we did, we know that we got the square root all by itself first. right? And then what did we do? We squared both sides, right? So we get 16 is equal to x squared plus 7, right? The square and the square root canceling each other out. So subtract 7, we get 9. So we get x squared equals 9. So we're actually back to having a quadratic equation here, but it's a simpler quadratic equation than what we've seen before. So if I go back to that previous page and we take a look at the quadratic equation that we had here, notice we had a constant term, an x squared term, and an x term. We had all three of those, right? And so then we went ahead and solved accordingly. Here we actually have a much simpler situation. We're missing the middle term. So if you're missing the middle term, what you can always do is just get the x squared on one side and the constant on the other, just like we have, and then undo the squaring, okay? Well, we kind of already know what to do there, right? Because when we wanted to undo a square root, we squared it. So if I want to undo a square, I should probably square root it. So here's what happens. We get x, okay? So undoing the square is going to be equal to the square root of 9, but not only the square root of 9, what I need to say is plus or minus. So the thing I want you to remember is if you are ever having a situation where it's x squared equals a number, right? And then you want to get x by itself, so you take the square root. You have to remember plus or minus. And the reason for this is simple. At this stage, what I'm trying to ask myself is, what number do I square in order to make 9? Well, of course 3 works, but guess what? Squaring -3 also gives you positive 9. So always remember that. Put a plus or minus when you have an x squared equals a number and then you take the square root. So my solutions, at least my prospective solutions, are 3 and -3. Now technically I should go ahead and check both of these. Make sure it works. So 9 plus 7 is 16. So g of 3 equals 10, just like it's supposed to, right? And g of -3, of course, is going to give me the same thing, no problem, because when I square that -3, it becomes positive 9, just like the 3 did in the previous one. So you get the exact same thing. So they both check out, no problem. So these are my 2 solutions.